For any program to be executed, it must be mapped to absolute address and loaded into the memory. We'll talk about these addresses, don't worry about that. All these addresses I'm going to tell you. But the basic idea is that for any program or any instruction or any data, if you make a program, say you make a program of Fibonacci series or factorial, then the instruction and data, all these program generate some error, and the program generates certain address. The address is what? These are the absolute address. But when the program terminates, the memory space is being freed, or you can say the program terminates and its memory space is declared available so that next program can be loaded. And in order to improve the CPU utilization, we want several programs to be kept in memory. And this memory management scheme is closely related with the hardware design also. So what are the management or memory management activities for which operating system is responsible? First of all, to keep track of which part of memory are currently being used and by whom. Whenever I am talking about memory, I am talking about the main memory, okay? So deciding which to be loaded, when the space is available, and then allocating and deallocating memory space as required. So basic hardware is something like this. Just take, whenever I am speaking, just have a look on this diagram also. That means the program needs to be bought. If this is your backing store, you can say hard drive, backing store. Now the program has to be bought into the memory. So this is the memory from the disk. If this program is in this memory, main memory, then only it can be executed. So the main memory and register, they are only stored, they only the places where the CPU can talk. So CPU can directly deal with two things, main memory and registers. So register access is generally one CPU clock, while the main memory access can take various cycles. And in between this main memory and CPU register, you will find the cache also, cache sitting in between them. So we have some protection strategy also, that is a pair of base and limit register. These are all hardware stuff. So we have base and limit register, which defines the logical or virtual address space. Please understand, we'll be talking about logical and actual, that is the actual this space. So this logical or virtual address space, the pair of base and limit register define this. For example, see, this is what? This is your base, this is your limit, right? How you have gone to this limit, or how we have received this limit? What we have done is, this is the upper limit. We have subtracted these two, that is the lower and upper, or you can say you have subtracted, or this space between the base and the highest one for any process is the logical address space. I hope you got the idea. This is the logical address space for this process.